Hi guys, welcome back. Today we will be discussing problem number 34, finding first and last position of element in sorted array. We will be given an array sorted in non-descending order. Our task is to find starting and ending index of a given target value. So let's see an example. Given example is 5, 7, 7, 8, 8 and 10. So and target equal to 8. So we need to find starting index of 8 and also the ending index of 8 and return that. So here, if you see it is 0th index, 1, 2, 3, 4, and 5. So 8 is starting at third index and ending at fourth index. So here our answer is 3, 4, which is this one. So if target is not found, so here they're asking us to return -1, -1. Yeah. So to solve this, brute force solution would be iterating through the array from left to right and checking if we found the target. So if we found the target, then it will be starting index, and from there we will iterate it further to find the end index. When we found any number greater than the target, then yeah, I mean we have encountered the next element which is not equal to target, so we can return that end index. I mean whatever we have achieved so far. So that would be brute force solution, but the time complexity of this is order of n. We can do a better solution. I mean, since the array is sorted, we can apply binary search on it to get the first index and start an index. But we need to modify a bit of the regular binary search that we do to get the index of the element, or to check if that particular element is present in the array or not. So let's break this problem to two sub problems. So first one is finding the first element. So first problem is find first element, first index. I mean, and second one is find the find last index. So if we find the first index, so then we can append it to the answer, and then let's find the second index and we can append it to the answer. So for this, we need to modify that binary search a bit. So let's first see how general binary search will be implemented. So in binary search, we will have low, I mean, defined as 0, and then we have high as length of the array -1, and then we will have this while loop for low less than or equal to high. Then then we will take mid value. Mid equal to low plus I by 2, and then we check if this array at mid equal to the target, then we return this mid index. If this array at mid if this array at mid is greater than the target, so see the target is less than the middle element, so the target will be in the left side. So we need to decrease our range to our high. Need to decrease our range high to our mid -1. If this is greater than the target, if mid is greater than the target, less than the target, then we need to increment the range. So we need to change low to mid minus mid plus 1. So this is, and if we did not find the element anywhere, we will return minus 1. So this is general binary search, but here we need to find the first index and last index. To find the first index, see here if whenever we find the element, we are just returning. But it could be possible that this element might be present in the left side also and right side also. So while finding the first index, we don't need if it is present in the right side. So we'll only concentrate, I mean, if it is present on the left side to finding the first index. Okay. So instead of returning it from here, we can, I mean, we can update the index that we got so far. So far, let's see the result will be instead of returning it from here, we will let me erase this. Instead of returning it from here, what we'll do, so instead of returning it from here, we will update the result to this mid. So, and we will check on the left side if we have that target further, and so that we will need to decrement the range. So this end index will be mid minus 1, end index or high value. So yeah, so to find the first index, so we are not returning when we found the element. We will need to decrease the range to the left side, so that if we have that element in the left side, we will do binary search further. And if we did not find, if there is only one occurrence, then we anyhow have this result in the mid, and at the end we will return, instead of minus 1, we will return the mid. We will return the mid. And if we could not find this element in the array at all, anyhow we will initialize the result to minus 1. So similarly, for finding the last index, so if we are at the mid, then we don't need to we have one occurrence, we have one occurrence of the target, so we don't need to worry about the left side if it is present or not. So we can decrement the range to this array. So we will change the start index to this position, which will be low will be equal to mid plus 1 to high. So in this range, we will search for the last occurrence. So if we could not find it, then well and good, we still have the result updated to mid. So we will return the same. So we need to write two functions. The first function will return us the first occurrence of the element, and the second function will return us the second occurrence of the element. So this will be the pseudocode for that. So let's quickly write the code and see. Let's first write the functions, and then let's write this search ring. So first function will return us the index where that element is present. Find first index, which will take nums and target. Let's initialize low value to 0 and high value to nums dot length minus 1, and let's initialize index equal to minus 1. So we will apply binary search while low is less than or equal to high. Calculate the mid equal to low plus I minus low by 2. So why this instead of, I mean, if we write low plus high by 2, then this might overflow. So that's why we need to, I mean, whenever we are applying binary search, we need to do something like this. We need to add the middle element to the low instead of adding low plus high, because this might go out of overflow. I mean, this might go out of the index range. So that's why we need to, every time we need to do this. So now we will check if nums at mid equal to target. So generally in binary search, if this is the case, we will return this. So the index we found. So I'll return the index. But now we found the index, but it is also possible that the same number might be present in the left side as we discussed. So we will update the result, which is the index that we get so far, and equal to this mid, and we will continue to search further in the left side. So searching on the left side, and will be, I mean, high will be equal to mid minus 1. Now, if num set mid is greater than, so the number that we have is greater than target. So we need to search in the left side. So we need to decrease the range to the left side. So high will be equal to mid minus 1. Else we need, so if nums of mid is greater than target, then we need to search it in the right side. So low will be equal to mid plus 1. So at the end, when we break out of this while loop, we will return the index. So I mean, similarly for finding the last occurrence, you can just simply copy this. So whenever we found the mid, so instead of going into the left side, we will go into the right side. Low equal to mid plus 1. So we'll search in the right side if we have any other occurrence for the target. So let's rename this function name, and this should do. And here, let's initialize the result equal to new int of, it should be of length 2. So result of 0 equal to is find first index. Once target, this will return the first index and it will put it in result of 0, and in result of 1 equal to find last index. Then the rest, this should do. Okay, there is some mistake in the find first function. Okay, so yeah, here from here we need, yeah, this if state is getting executed 2 times. But so instead of this, we would have written something like set get is less than target, then only will have to do this. And name here num set get less than target, then we need to do this. Let's try running and see. Let's quickly submit. Yeah, it got accepted. So that's it for this question. So